Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is the Mechanics, for May-June 2023, and the code is 9709/43. Okay, so let's move on to question number 1. Now for question number 1, two particles P and Q of masses 0.1 kg and 0.4 kg respectively are free to move on a smooth horizontal plane. The particle P is projected with speed 4 meters per second towards Q, which is stationary. After P and Q collide, the speeds of P and Q are equal. Find the two possible values of the speed of P after the collision. Okay, so from here I can just draw this diagram. Okay, let's say this is a P and this is a Q. Right? So it's mentioned that the MP is 0.1. So MP is 0.1 kg. Then the MQ is 0.4 kilograms. Now, P is projected with speed 4 meters per second towards Q. That means the UP is 4. Okay, and the Q is actually stationary, means that UQ equals to 0. This is the diagram for before collision. So after collision, right, after P and Q collide, the speeds of P and Q are equal, means that I will expect both move to the right side. And then I will let both be V, the speed, and then this is a P and Q. Okay, so this is before collision and after collision. Right, so from here, to solve this question, to find the speed after the collision, we need to refer to the conservation of linear momentum. Okay, so conservation of linear momentum means MP UP plus MQ UQ. This is the momentum, total momentum before the collision. Then it will be same as MP V, because the speed is V, plus MQ V, which is the momentum after the collision. Okay, so now I will replace all the values. So my MP is 0.1. Then the UP is 4. Okay, I will assume to the right side is positive. Okay, the U to the right side is positive. Then plus MQ is 0.4, but the UQ is 0. Equals to MP again 0.1, V plus MQ is 0.4, then multiply by V. So from here, the left hand side is 0.4, right hand side you will get 0.5 V. Okay, and now we need to find two possible values of P. Alright, so here we will be getting the first V. So my V is 0.4 over 0.5, which is 4 over 5 meter per second. Now I need two values. So just now I assume after collision P and Q moves in the same direction, means that towards the right side. So another possible outcome may be, or after collision, right? Because at first the Q is stationary, not moving. So when the P moves towards Q, all right, after the collision, it might be the P moving in the reverse direction. So this may happen, all right? But then the Q start moving to the right side. This is our Q. So let's say here V. Now for the right hand side, when you refer to here, okay, so for the P, I will write minus V, okay, because it is opposite direction. So here we consider the velocity, right? So means that use back the same formula, alright, I will get 0.1 times 4. Before collision, it will be remain the same, right? So I will just copy this. then plus 0.4 times 0 equals to, after collision, the m is 0.1 kg, and then the velocity now is minus v. Okay, then plus 0.4 times v. So from here, the right hand side will be 0.3 v. The left hand side remains as 0.4. Therefore, my v is going to be 0.4 divided by 0.3, which is 4 over 3 meter per second. So these are my two v values. So two possible values of speeds after collision equals to 4 over 5 meter per second. Another one is 4 over 3 meter per second. Okay, so this is the solution for question number 1. Now question number 2, a car of mass 1,500 kilograms is towing a trailer of mass m kilogram along a straight horizontal route. The car and the trailer are connected by a tow bar which is horizontal, light and rigid. There is a resistance force of F Newton on the car and the resistance force of 200 Newton on the trailer. The driving force of the car's engine is 3,200 Newtons and the acceleration of the car is 1.25 meter per second squared. And the tension in the tow bar is 300 Newtons. Find the M and the F. Okay, so for this, I will draw the diagram. Let's say this is a car. Alright, and then this is the trailer. Okay, so now this is the string. Okay, this is a tow bar. I would say this is a tow bar, right? So here you have tension. This one you have tension. And then this M is 1,500 kilogram. And then this is M kilograms. Now the resistance force of Fn on the car. Okay, so which means here I will have F, right? F Newton. This is a resistance force. And then the resistance force of 200 Newtons on the trailer. Because when the car is moving, okay, it's towing this trailer, that means I will expect it moves to the right side. So the resistance force will be towards the left hand side, which is in the opposite direction. So for the trailer, I will have 200 Newton. Right? And then it's given that the driving force of the car's engine is 3,200. So here I will write driving force equals to 3,200 Newtons. Acceleration is 1.25. So A equals to 1.25 meter per second squared. The tension is 300. This T is 300. Right? So now, to solve this question, to find the M and also the F, so we need to refer to the Newton's second law, which is from F equals to ma. This is a Newton's second law. So now I will consider the car first. Okay, which means we concentrate on this. Now, for the F is the force. So from here, the car has driving force. Therefore, it will be 3,200 minus the F over here. Alright, so I will use this. So this is a driving force minus F minus tension. Alright, that will be my total force for the car. So my F remains, my T is 300. Then it will be, the M of the car is 1,500. Then the A is given 1.25. Okay, and now we can find the M first. So from here, 3,200 minus 300 on the left hand side, it will be 2,900. Then minus F. Right hand side 1500 multiplied with 1.25, it will be 1875. Therefore, my F is going to be just move to the right side, and this 1875 move to the left side. I'll get 2900 minus 1875. Then it will be 1025. So that is my F. Okay, and now we need to find the M. So the M is on the trailer. That means now I need to refer to the trailer. So this is by referring to trailer. Now it's still the same using F equals to MA. Okay, so now since we are referring to this trailer is moving to the right side. You see here, arrow, right side. Therefore, I will now refer to this. Okay, so then my force will be my forces will be T, right, which is a tension, 300 minus the resistance force, 200, that equals to MA. So the M remains, the A still the same, 1.25, because it is connected to the car. So from here, I will get 100 equals to 1.25 M. Therefore, your M is going to be 100 over 1.25. Then you will be getting 80. So that is the M value. Okay. So for question 3. Now a smooth ring R, this is a smooth ring, of mass 0.2 kg is threaded on a light string ARB. So this is the ARB. Okay. So the ends of the strings are attached to fixed points A and B. Fixed points A and B, with A vertically above B. The string is taut and angle ABR is 90 degrees. So ABR here. The angle between the parts AR, alright, the parts AR, and the vertical is 60. That means here is a 60 degrees. The ring is held in equilibrium by a force of magnitude X Newton. Equilibrium means that it is not moving, right? Acting on the ring in the direction perpendicular to AR. So see diagram. Now calculate the tension in the string and the value of X. So we have to solve two parts here. Now for your information, since the ARB is the thread, means that it is a string. ARB is a string, so means that you will have the tension over here, right? Then from here, if I just refer to the tension applied to the R, okay, then now from here I will just resolve. So I will resolve vertically. Okay, so resolve vertically. Now from here, since this is 60 degrees, right, that means I will say here is 60 degrees, because you can see the opposite, the butterfly shape. Okay, this is a property of the angle. Here is 60 degrees. Here is going to be 60 degrees. Okay, then for the R, because the mass is 0.2 kg, so the weight will be going down. It will be 0.2 G. G is 10. Okay, then from here I will resolve. So firstly, I will resolve vertically. I will resolve the T up, alright, vertically. Then I will get T cos 60 degrees, because I'm using the angle 60 degrees. Then I will get T cos 60 degrees. Then don't forget, you still have the X over here. So this X will be resolved vertically as well. So if here 60 degrees, I know that this is going to be 30 degrees. So again, I resolve the X vertically using 30 degrees, means that it will be cos. Otherwise, you can use cos 30, or probably you can use a 60 degrees over here, but then you'll use sine. Okay, so here it will be plus X cos 30 degrees. Now, these are the two vertical forces, and then it will be same as the downwards force, which is 0.2 G. Okay, so I get these three forces where I resolve them vertically. Now, from here, I need to simplify it. Cos 60 degrees is basically half. The first term becomes half t. Cos 30 degrees is square root 3 over 2. Okay, then 0.2 g. The g is basically 10. That means I will get 2. So here you get 0.2 times 10. Right, then I will simplify. It will be half t plus square root 3 over 2x equals to 2. This is my first equation. Now the second equation is to resolve horizontally. So when I resolve horizontally, right, so it means that I have to resolve over here. So I will move this t down. Okay, so when I move down, my angle is over here 60 degrees. So I'm not using this angle, I'm using the 60 degrees, therefore it will be t sine 60 degrees. So then I will get t sine 60 degrees. Okay, and you don't forget that, see here, when I resolve this down, right, then here I still have one more t. It means that now the total forces towards the left hand side will be these two. So I need to plus another t. Okay, then I may resolve this xn horizontally as well. So since here is 30 degrees, means that, right, you may use sine 30 degrees when you resolve. So x sine 30 degrees. So sine 60 degrees is basically square root 3 over 2. Sine 30 degrees is half. Okay, so from here, I will get t bracket 1 plus square root 3 over 2 equals to half x. So this is my second equation. Now I will substitute second equation into first equation. So second equation into first equation. Now for your information, okay, this I'm going to replace my half x by this term, the t bracket 1 plus root 3 over 2. So this part, this term is basically square root 3 times half x. Okay, so then I will be getting half t, second into first, so I remain half t. Instead of square root 3 over 2x, I will change to square root 3 times half x. So it will be plus half, is it plus square root 3, square root 3. Then my half x will be replaced by this t bracket 1 plus square root 3 over 2. So I will get t bracket 1 plus square root 3 over 2. Then right hand side equals to 2 in the first equation. Okay, and now we can find the t because this equation only has one t. So I can just do expansion. This square root 3 times t times 1, it will be plus square root 3t. Then this square root 3 times square root 3 is 3. So 3 over 2t. Then equals to 2. So 3 over 2, 1 over 2 plus 3 over 2 is basically 2. So I will get 2 plus root 3t equals to 2. Therefore, my t is going to be 2 over 2 plus root 3. Okay, so then you can just calculate your answer correct to 3 significant figures. That means my t is going to be 0.536. So that is my t. And we know that the t is in newtons. Therefore, you can just add on the newton. Alright, so we have done the t. Okay, now done the tension. Now to find the x. So to find the x, just use either the first equation or second equation. The easiest is to use the easiest way is to substitute into the second equation. So I will just write from second equation. My half x is going to be the t. Okay, this t I will replace by the actual value. So it will be 2 over 2 plus square root 3. That is my t. Then 1 plus square root 3 over 2. So now my x, this half moves to the right side, becomes 2 bracket 2 over 2 plus root 3. And then for the second bracket, I can make it to the same denominator, which is over 2. Then numerator will be 2 plus root 3. So from here, the two brackets can be cancelled off because exactly the same. Alright, that means your x is going to be 2. So that's the solution for this question number 3. Okay, question number 4. A lorry of mass 15,000 kilograms moves on a straight horizontal line, horizontal route in the direction from A to B. It passes A and B with speeds 20 meter per second and 25 meter per second respectively. So that means this is a speed at A, this is a speed at B. Now the power of the engine is constant and there is a resistance, constant resistance to the motion of magnitude 6,000 newtons. The acceleration of the lorry at B is 0.5 times the acceleration of the lorry at A. Now A, show that the power of the lorry's engine is 200 kilowatt. This is the first part. And hence means use these 200 kilowatts to find the acceleration of the lorry when it is traveling at 20 meter per second. Okay, so now here, I will just draw the diagram. Let's say this is a lorry, right? The mass is, the M is 2 points. Okay, so I will say this is a point A first. This is a point A. Then probably here is the point B. Okay, the M is 15,000 kilograms. And then the UA is 20. So UA is 20 meter per second. The UB is 25 meter per second. Now, there is a constant resistance to the motion. So let's say the lorry is moving to the right side. So the resistance will be towards the left hand side. And this is 6,000 newtons. Then the acceleration at a B. Okay, so now AB, acceleration A, right, it is denoted by small a. At the B, this is the acceleration at the A. So it's given that AB here is 0.5 times of the A acceleration at point A, means it's half of A at the point A. Okay, so now at the point B, we still have the resistance to the motion, which is 6,000 newtons. Okay, so from here, to find the power, we know that power P equals to Fv. Okay, so now we know that there will be a driving force. So here I will label driving force D from the engine. So now your P, so from here I let D be the driving force. That means instead of writing F, I will change to P equals to dV. Okay, and now from here, I need to know what is my driving force that I will apply in the Newton's second law. So my driving force is basically P over V. So the V here is basically UA. So it will be P over 20. This is my driving force of the lorry's engine. Now, from Newton's law, F equals to ma, Newton's second law. So it will be, when you look at this, look at here, alright, so it will be a driving force minus the 6,000 newtons equals to the M is the lorry mass, which is 15,000. Then the A is not given, so I just let it be A first. Alright, so then from here, at the points A, okay, at A, so this D is P over 20. So in this case, because we need to consider both points, right, better just write D equals to P over V. So now, because at the point A, the U is 20. So I will change to P over 20, then minus 6,000 equals to 15,000 A. This is my first equation. Now, when it is at the point B, when you look at this diagram, okay, we still have the driving force, D here. So it means that now, my D minus 6,000, I will just replace my D. My D is P over V. So I do not know why it's a P, therefore remains. But then at the point B, okay, the U, the speed is 25. Okay, so here 25. Then minus again 6,000 equals to 15,000 A. So just now is mentioned here. See, AB equals to half AA. So if I let my A, the acceleration at the points A be small a, that means my AB equals to half A, whereby my A at the points A is small a. Okay, so it will be half of A. This is my second equation. So to solve this, let's look at the question. We need to show the power. So if you need to show the power, means that you need to find what is a P, which means I need to eliminate the A. So I notice that 15,000 A, 15,000 A. Okay, so I will replace this 15,000 A with this first equation. So which means now I will write first, substitute into second. So the left hand side of second equation will be P over 25 minus 6,000. Then the right hand side, I still have the half here. So half of 15,000 A. So the 15,000 A will be replaced by the equation number 1. So I will get P over 20 minus 6,000. Right? So now I will do the expansion for the next step. P over 25 minus 6,000. This half I times it. It will be P over 40 minus half times minus 6,000. It will be negative 3,000. Okay, then now we need to get the P. So P over 25 minus, so I will group all the P on the left hand side and the rest move to the right side. So now P over 25 minus P over 40, it will be negative 3,000 plus 6,000. Then the left hand side, P over 25 minus P over 40, it will be 3 over 200 P. Then right hand side, it will be 3,000. Okay, therefore my P is going to be 3,000 multiplied with 200 over 3. Then it will be 200,000 watt. And this is also same as 200 kilowatt. So this is how we prove the P value. Okay, which is the first part. Now, after you have found the P here, we have shown the P here, then the next is hence use this. Okay, hence means use the 200 kilowatt to find the acceleration of the lorry when it is traveling at 20 meters per second. So when it is 20 meters per second, is basically at the point A. Right? So I will refer back to the first equation because this first equation comes from the point A. Alright? So now I will show the working over here. So then from first equation, right, P over 20, so the P is 200,000 over 20 minus 6,000 equals to 15,000 A. So when you simplify, the left hand side is going to be 15,000. Now I will rewrite the 15,000 A first. Then the left hand side, basically, if you simplify, this 0 cancel, this 2 here becomes 1. So it will be 1, 0, 0, 0. Means it's 10,000. 10,000 minus 6,000. So I will get 4,000. Therefore, my A is going to be 4 over 15 meter per second squared. Right, now the lorry begins to ascend a straight hill inclined at 1 degree to the horizontal. It's given that the power of the engines and resistance force do not change. Find the steady speed up the hill that the lorry can maintain. Okay, so now I will draw the diagram. Let's say here is 1 degrees. This is the lorry. We still have the driving force, and then we have the resistance force here as well, which against the motion. This is 6,000 newtons. And then the lorry mass is 15,000 kilograms. I mean, it will be 15,000 G. Okay, this is the weight because the mass is 15,000 kilogram. So here I will write 15,000 G. Okay, so from here, again, to solve this question, we need to use Newton's second law. So F equals to ma, but it's given steady speed. So steady speed means that the A equals to 0. No acceleration. Okay, so from here, again, we just resolve. Right, let me draw this first, then you can see clearly. Right, so I need to resolve. Okay, so what I need to do here is my driving force. My F is still driving force, so driving force minus 6,000. Now, when you resolve here, you remember this green arrow is 15,000 G. So I have to resolve it to so that it will be parallel to the plane, right? So when I resolve it parallel to the plane, you see here is 1 degrees. Okay, here is 1 degree. I'm not using this angle, but I'm using 1 degree. Therefore, it will be sine. Okay, so I will write minus 15,000 G, then sine 1 degree. Then equals to M is 15,000. Then my A is going to be 0. Okay, so again, your D is P over V. Then I move all the terms to right side, because we need to find the steady speed. Here is the speed. So then it will be, the right hand side will be 0. This is going to be 0. So these two terms move to right side becomes positive. Then I will get 6,000 plus 15,000 times 10 for G, then sine 1 degree. Okay, so now my P is mentioned that the power of the engine do not change or does not change. So I will use back my P from the previous calculation, which is 200,000. So I will write 200,000 over V. Right hand side here, when you do the calculation, it will be 8617.861. I give more decimal places because this is the working, it's not yet the final answer. Then now to get the V, just move up the V and move down the right side. Okay, just cross multiplication. Then it will be 200,000 over 8617.861. Then you will get 23. Okay, this is already a final answer. No more calculation after this. So I will just round up directly. So it will be 23.2 meter per second. If you still have next calculation, we might need to use the V value from this part. Then it's better to give more decimal places or more significant figures. So this is a final answer for the speed. Okay, now for question number 5. A particle starts from rest from a point O and moves in a straight line. The acceleration of the particle at the time t after leaving O is a meter per second squared, where a equals to kt degree half for t from 0 to 9, inclusive, where k is a constant. The velocity at the particle at time t equals to 9 is 1.8 meter per second. Now A show that k equals to 0.1. So from here, right? Now for your information, this is acceleration. Okay, so the displacement S will be changed to V by differentiation. Okay, then to get the A from V, we again differentiate. So now we need to get the relationship between A and V, because now you are given the A. I need to get the V because you are given the V value. Therefore, it is a reverse process. Therefore, we have to do integration. Okay, so now I will write my V is basically integrate A dt. So replace the A by kt to the power of half dt. When you need to integrate, remember the formula. So integrate, let's say ax degree n dx. A is a constant, so you take out the a, it will be x degree n. Then here is going to be a, then x to the power of n plus 1 over n plus 1, followed by plus c. So this is the integration formula. Therefore, I factorize a k. Integrate k power t to the power of half. It will be t to the power of 3 over 2 because you plus 1 to the half. Then divide by 3 over 2 means it is the same as times 2 over 3 plus c. So before you get the k, you must understand that it starts from rest. So when it starts from rest means that the t equals to 0, the v equals to 0. Then from here, 0 equals to k 2 over 3, 0 plus c, which means my c is 0. Okay, then now we will use these two values to get the k value. So, which means now my v is basically 2 over 3k times t to the power of 3 over 2. That's it, because your c is 0. So now when t is 9, your v is 1.8. So when t is 9, your v is 1.8. That means 1.8 is 2 over 3 times k times 9 to the power of 3 over 2. So 1.8 is going to be 2 over 3 times k. The 9 to the power of 3 over 2 is basically 27. Then from here, you will get 18k equals to 1.8. Therefore, your k is 1.8 divided by 18, which is 0.1. So with this, we have shown the working. We have shown the k value. Now, for t greater than 9, the velocity v meter per second of the particle is given by this. Show that the distance traveled in the first 9 seconds is 1/10 of the distance traveled between t equals to 9 and t equals to 18. So now, you need to get the distance for the first 9 seconds. So you refer to this, right? We have found the v just now. To get the s, I need to integrate the v. Okay, even though the s is the displacement. So now my v is going to be kt 2 over 3 kt to the power of 3 over 2. So now I need to integrate this. So from 0 to 9 seconds, my V is 2 over 3, 0 0.1, sorry, my 2 over 3 K is 0 0.1. Okay, 2 over 3, 0 0.1, T to the power of 3 over 2. So when you calculate this, 2 over 3 times 0 0.1 is basically 1 over 15. So this is my V. Alright, so now I get the S. So I let it be S1. This is my V1. S1 is integrate V1 dt. Then it is defined from 0 to 9. So I will integrate 0 to 9, the t values. So which means this is going to be 0 to 9. The 1 over 15 will be taken out. Then I will just integrate t to the power of 3 over 2. So here is going to be 1 over 15. Again, now when you plus 1 to 3 over 2, it becomes 5 over 2. Then you're supposed to divide by 5 over 2, but then now I move up, becomes multiply by 2 over 5. Then the limits will be 0 to 9. And then from here, I simplify, I'll get 2 over 75 multiply with 9 to the power 5 over 2 minus 0. So at last, you are getting 6.48 meters. Okay, that is for the S1. Now for the S2, this is the V. So I will just copy back this. So from 9 onwards, or it is from t more than 9. Okay, now you need to find the distance is 1/9 of the distance traveled between 9 and 18. That means here I will change to 9 and 18. So now my V2, I will just copy from the given V here. Right, so 0 0.2 times t minus 9 squared plus 1.8. Again, the S is the displacement is the integration of the V2. So now my S2 will be integrate from 9 to 18 V2 dt. So it becomes 9 to 18, 0 0.2 bracket t minus 9 squared plus 1.8 dt. So to integrate the first term here, I will have to use ax plus b to the power of n dx. Then you rewrite, provided the n is not minus 1. Okay, so you rewrite the whole function. The degree becomes n plus 1, then over n plus 1. Now you differentiate the ax plus b, it will be a plus c. Okay, this is the formula that I'm using. Now, I will get 0 0.2. Then instead of t minus 9 squared, I will write t minus 9 degree 3 over 3, and differentiate t minus 9 is actually 1. So you can just leave it. The 1.8 dt becomes 1.8 t. And the limits will be from 9 to 18. Okay, so now you replace the values 0 0.2 over 3. I take out the 0 0.2 over 3 and replace the t by 18. Okay, replace the t by 18. Then minus when the t by 9. So 18 minus 9 is 9. So I get 9 cubed plus 1.8 18 minus 0 0.2 over 3 times 9 minus 9 is 0. Then plus 1.8 times 9. Okay, so from here, you will get 64.8 meters. So that's the S2. Just now our S1 was 6.48. So now you want to show that, which means I will continue over here. So S1 over S2, I get the ratio. It will be 6.48 over 64.8 meters. So obviously this is 1 over 10. Okay, which means S1 over S2 is 1 over 10. And now you want to prove that it is 1/10, right? So which means S1 is basically 1/10 of S2. So this is the proving part. Right? Now find the greatest acceleration of the particle during the first 10 seconds of its motion. We need the acceleration. So now I will rewrite the accelerations for the first 9 seconds. So I let it be A1. So where is my A? Okay, now it's given here. A is kt degree half, okay, which is here. And we have found the k just now. The k is 0.1. So I will just replace 0.1 square root t. When the t from 0 to 9, that is my A. I let it be A1. So it will be 0.1 square root t. Okay, so now we need to find greatest acceleration. So you can just find when t equals to 0, the A equals to 0.1 times 0, which is 0. Then when t equals to 9, because we know that the square root t, right, the graph is like this. So it will be increasing. So that's why I will just find the minimum and maximum. So my A1 is basically 0.1 times square root 9, which is 0.3. That is these two are my accelerations during the first 9 seconds. But then here, first 10 seconds. Now I need to consider when it is between 9 and 10 seconds, my A2. Okay, now when you refer back to the previous question, you are given the V, the velocity. It's not the V. It's not the A. So it means that now I need to get the A, right? When you refer to here, to get the A from V, I need to differentiate. So A equals to dV over dt. Means that now I need to differentiate this given V. So I will have to rewrite first. So this is dV2 over dt, which means I need to differentiate 0.2 times t minus 9 squared plus 1.8. So when I differentiate the first term with t, so bring down the power, 0.2 times 2 brackets t minus 9 degree 1. So I'm using this formula. Differentiate fx to the power of n. It will be n bracket fx to the power of n minus 1, then f prime x. Alright, I'm applying here. Then when you differentiate t minus 9, it will be 1. The 1.8 will be 0 because this is a constant, there's no t. Therefore, I will get 0.4 bracket t minus 9. That is my second acceleration. Now, since you need to find greatest acceleration during first 10 seconds, so now I calculate. When t equals to 9, okay, so A2 becomes 0.4 brackets 9 minus 9, which is 0. Then when t equals to 10, because this is a straight line, we know that this is a straight line. So A2 is 0.4 times 10 minus 9. Therefore, it will be 0.4 times 1, which is 0.4 meter per second squared. So now when you check these four values, 0, 0.3, then after that 0, 0.4, obviously the greatest acceleration will be 0.4 meter per second squared. Therefore, alright, that's the solution of this question. Or from here, you can just write the A2 is between 0 and 0.4 meter per second squared. Okay, then here it will be A1 between 0 and 0.3 meter per second squared. Then you can see clearly. Right, so the maximum is going to be 0.4 meter per second squared. Okay, now question number 6. An elevator is pulled vertically upwards by a cable. Then the elevator accelerates at 0.4 meter per second squared for 5 seconds, then travels at constant speed for 25 seconds, then decelerates at 0.2 meter per second squared until it comes to rest. So when come to rest means that the velocity will be 0. Now A, find the greatest speed of the elevator and hence draw the velocity time graph for the motion of the elevator. Okay, since now you are given the acceleration, alright, so for t from 0 to 5 seconds, the acceleration is 0.4. So the a equals to 0.4, and we know that the elevator is pulled vertically upwards, means that the u equals to 0. Then, and now from here, to get the v, right, since you have t, you have 0.4, you have 0. That means v equals to u plus at. And then the v is unknown, the u is 0. A is 0.4, is given here. The t is going to be 5. Okay, because for 5 seconds. So I would say t is 5. Then from here, my v is going to be 2 meter per second. Because we know that it accelerates after that constant speed, and then decelerates, means that this 2 meter per second is a greater speed. Therefore, greater speed equals to 2 meter per second. Alright, so now when we need to draw the graph, so this is v, here is a t, 0. Okay, so for first 5 seconds, the acceleration is 0.4. So when 0.4, greater speed is 2. And now we are drawing velocity time graph. So I will label here 2, then 5 seconds. After that, constant speed for 25 seconds. So 25 seconds from 5 seconds means that it will be 30. So now, let's say here's 10, here 15, 20, 25, 30. So it will be constant speed. Make sure it is a horizontal line. Okay, after that, it decelerates as 0.2 meter per second squared. So now I need to find what is the time, okay, for it to come to the rest. So now, when t is greater than 30, okay, v equals to u plus at. Again, when comes to rest, that means that v equals to 0. Alright, that is the final velocity. Then now the u here will be this. Okay, so the u will be 2. Hang on, please. So the u is 2. Then the a is given. But it's mentioned that decelerates means that you have to put a negative to this value. Otherwise, it's considered as acceleration. Okay, so I will get negative 0.2. Then t is unknown. I need to find how long time when it comes to rest. So from here, 0.2t equals to 2. Therefore, t equals to 2 over 0.2, which is 10. That means 10 minutes after the 30 seconds, it will come to rest. So here will be 35, then this is 40. This will be your graph. Okay, so this is the velocity time graph. Right, now B, find the total distance traveled by the elevator. So the distance is basically, the total distance traveled is basically the area under the curve for the velocity time graph. So now I will write total distance traveled equals to total area under VT graph. right? So when you look at the graph here, it's actually a trapezium. So trapezium, for your information, if trapezium, let's say 2 parallel sides, and then the height is c, so the area of trapezium is basically half of a plus b times c. Okay, so now your a here is basically 30, right? Then your b is 40, and then the c is basically 2. So now I will write half of 30 plus 40. Sorry, is this 30? Okay, here is 30, here is 30, then this is 5. That means it should be 25. Okay, constant speed for 25 seconds. So here 25. So it will be 25 plus 40, sum of the 2 parallel sides. And then the height is 2. So obviously the half and 2 cancel off. The middle value is 65. So that is the total distance traveled. Now, the mass of elevator is 1,200 kilogram, and there is a crate of mass m kilogram resting on the floor of the elevator. Given the tension in the cable, given that the tension in the cable when the elevator is decelerating is 12,250 newtons, find the value of m. Okay, this means, let's say this is the elevator, right? There's a crate. So the weight for the crate is mg. The mass of the elevator is 1,200 kilogram. Means that the weight for the elevator will be 1,200 g. Okay, and there is a tension. This is the tension of the cable. It is 12,250 newtons. So now to get the m, I will refer this to Newton's second law. So my A is going up. Now my F equals to ma, which is a Newton's second law. It will be T minus 1200 g, the weight of the elevator, then minus mg, which is the weight of the crate, equals to the total weight here. The m here is the total. Okay, the total weight here will be 1,200 plus the m. And then A is unknown. Okay, so now from here, when it's mentioned decelerates, see, when the elevator is decelerating, so based on the previous question, okay, decelerates at 0.2. So now I know that this is my A, but it is negative. So then I will write 12250 minus 1,200, the G is 10, then minus m times 10 equals to 1,200 plus m. My A is negative 0.2 from the question. Then from here, the left hand side, when you count these two values, it will be 250. Then the last term will be 10m. Then the right hand side, I will just do expansion. So 1,200 times negative 0.2 is basically negative 240, then negative 0.2 m. And this negative 10m will be moved to the right side. Then this negative 240 move to the right side because we need to find the m now. So I will get 490. 250 plus 240 is 490. The positive 10m minus 0.2 m, it will be 9.8 m. That means my m is going to be 490 over 9.8, which is 50. That is my m value. Okay, now D. Find the greatest magnitude of force exerted on the crate by the floor of the elevator. State the direction. So first is magnitude, second is direction. So when you refer to the, this is the elevator, when you refer to the crate itself, right? So here we will have the R, normal reaction, and then this is the 50G because we have found the M just now. And now we know that the A is 0.4. Okay, because it's mentioned the greatest magnitude will happen, or the greatest force, I would say greater force will happen when the elevator is accelerating. So the greatest force exerted on the crate by the floor of the elevator exists when the elevator is accelerating. That's why I'm taking A equals to 0.4 because it's given in the question here. Okay, so now again we use F equals to MA to solve this question. So since your A is going upwards, means that R minus 50G, which is a mass, this is a weight, equals to 50 times 0.4 because we just look at the crate here. Alright, so your R is going to be 50 times 0.4 plus 50G. G is 10. That means you are getting 520 Newton. So that's why the greatest magnitude of the force. Okay, so the greatest magnitude of force equals to 520 N. That is the R. Then what is the direction? You need to state the direction. So the direction will be upwards because your A is because we know that it must be it will be happen when the elevator is accelerating. So direction is upwards. Okay, so that's the solution for this question 6. For question 7, the diagram shows a vertical cross-section XYZ of the rough side. Okay, all these are rough. The section YZ is a straight line of length 2 meters, inclined at the angle alpha, this is alpha, and sine alpha is 0.28. So sine alpha is 0.28. The section YZ is tangential to the section XY at Y. So this is the Y. And X is 1.8 meters above the Y. So here is 1.8. A child of mass 25 kilograms slides down the slide starting from the rest at X. That means it's here. Okay, starting means U equals to 0. And we know that all these are rough planes. And then the weight is going to be 25G. The work done by the child against the resistance force in moving from X to Y is 50 joule. So this is the resistance force, right? Not resistance force. This is the work done. So work done. Okay, now A, find the speed of the child at y. You need to find when it reaches here. What is a v? So from here, I will use the work energy principle. Alright, which is increase in mechanical energy equals to total work done. So increase in mechanical energy is basically the increase in, this is basically increase in kinetic energy plus increase in gravitational potential energy. It is also same as final kinetic energy minus initial kinetic energy, that is the increase in KE, plus increase in PE, it will be final PE. PE is the potential energy minus initial PE. Okay, the total work done is basically the work done by forces to speed up the body up, then minus total work done by forces to slow the body down. Okay, so which means here we don't have the work done to speed up, but then we have the work done to slow down, which is the work done by the against the resistance force. So it means that it will be 0 minus work done against resistance. Okay, force. Alright, that is our formula. So the final KE, let's say now, see this is a V, and remember our M is 25. Okay, so the M is 25 kg. So the kinetic energy formula is half mv squared. This is basically half mv squared. Alright, so then I will get my M is 25, my V is what you need to find here, minus initial kinetic energy, half, the M is 25. Remember, at first, it is at rest, right? It's starting from rest at x. That means your U equals to 0. So if U equals to 0 means that the kinetic energy will be 0. This is the initial kinetic energy. Then plus the final PE. So final PE, I treat this as horizontal plane. Right? That means at here, the height will be 0. So it will be mgh. This PE is mgh, potential energy. So I will get half tan 0 minus initial potential energy, half tan. The h here is basically 1.8. So I will get 1.8. That equals to 0 minus work done against resistance force is given, which is 50 joule. So I will write 50. Okay, so when you look at here, the second term 0, third term is 0. So then I will get half times 25 is 12.5. Then V squared. This term will be moved to the right side. So I will get negative 50 plus 25 times 10 times 1.8. Which means here I will be getting 400. Then my V squared is going to be 400 divided by 12.5, which is 32. And hence, the V is going to be square root 32. And then you can leave your answer in the simplest form, which is 4 root 2 meter per second. There is a speed of child at y. Okay, now, it's given that the child comes to rest at z. use the energy method to find the coefficient of friction between the child and YZ, giving your answer as fraction in its simplest form. So now we have found the V just now, which is 4 root 2. Okay, so here this is V equals to 4 root 2. But then when it comes to Z, okay, the V2 becomes 0. So from here, use back the same formula, right? But now I will write work done against friction, because now we have a friction. Just now also have friction, but it's given already. But here now it's not given. Okay, work done formula is FD. But then here we will write minus FD because it is the friction, right? So now it will be negative F. The D is 2 because the distance here is 2 when we refer to this. So I will times by 2. Then you will get minus 2F. That is a work done against friction from Y to Z. Now use back the same formula, work energy principle. Okay, final KE minus initial KE plus final PE minus initial PE equals to total work done. So total work done now is negative 2F. Alright, so this is from Y to Z. Now I will just replace half M is 25. Final KE, the V will be 0 because when it reaches the Z, it comes to rest. Okay, so 0 minus half M. The initial KE means that we refer to the V at the Y. This is the Y, which is 4 root 2. Or I would say that it will be 32. Okay, V squared is 32 from the previous calculation. So it will be 32 plus final PE. Again, it already reaches the bottom. That means it will be 0 for the H. So I will get 25G0 minus initial PE. Okay, so when initial PE, look at here. We need to, this is our 25G. Okay, so the H is going to be, okay, this is a 2. I need to resolve this 2 vertically. Right, I resolve this 2 vertically. This is my distance. So if I resolve this here, I'm not using the alpha. Therefore, I'm not using this angle. I will say I will not using this angle. I'm using alpha. Therefore, it is sine. So my H is basically 2 sine alpha. That is my H. So when come to the working here, I will write 25G 2 sine alpha equals to negative 2F. Right? And now you need to find frictional force, the coefficient of friction. It will be later. So let's solve the F first. So first term, it will be 0. Third term also 0. Then my second term, minus half times 25 times 32, it will be minus 400. My last term on the left hand side will be negative 25 times 10 times 2. The sine alpha is given in the question, if you still remember just now, which is 0.28. So I will replace it by 0.28. That equals to negative 2F. So now from here, I will get negative 400 minus 140 equals to negative 2F. So my 2F is going to be 540. Then my F will be 270 Newton. Okay, and now you need to get the coefficient of friction. So our coefficient of friction is mu R. Now, it will be 270 equals to mu. Where to get the R? Okay, the R is actually the normal reaction. So let's say here. This is the R. Alright. Now when you resolve this weight to this part, so here is alpha, that means this is also alpha. So from this part, I know that my R is 25G cos alpha. That is my R. So this is 25G cos alpha. But then don't forget, just now you were given sine alpha equals to 0.28. So it means that, let's say, this is my alpha. Sine is opposite over hypotenuse. That means it's 0.28 divided by 1. But then now I need cos. Cos is adjacent over hypotenuse, which means I need to find what is this length, which is Pythagoras theorem. By using Pythagoras theorem, it will be 1 square minus 0.28 squared. And then we'll calculate this value, it will be positive 24 over 25. Okay, so from here I'll get 270 equals to mu 25 times 10. Cos alpha is going to be adjacent over hypotenuse, means that it's 24 over 25. Alright, so now your mu, you can just cancel off the 25. Then this is 240 on the left hand side. Then I will get 270 over 240. Which means you are getting 9 over 8. So this is the coefficient of friction for this question. Okay, so we have come to the end of the video. Thanks for watching. Please subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.